Okay, so we're going to go for quality rather than quantity in this last little bit here. We're going to try and find the slope of the tangent line, dy by dx. So slope of the tangent line there. And to do this, let me note something for us, that dy by dx can also be thought of as dy by d theta over dx by d theta. And when you're talking about r as some function of theta, this is what you're going to have to do to try and find the slope of the tangent line. Now, how does that equate to everything here? If I differentiate y with respect to theta, you actually have to use a product rule. Because even though it doesn't look like it, r is a function of theta. So it's r of theta times sine of theta. And in a similar way, this is r of theta times cosine of theta. So if I use the product rule here, what I'll get is r prime of theta, which is equivalent to f prime of theta, times the sine of theta, plus f of theta, maybe we should just write that as f of theta instead of r of theta, times the derivative of sine. Derivative of sine is cosine, so f of theta times cosine of theta. And we're going to have to do the same thing in the denominator. In the denominator, let me rewrite this up here as f of theta times cosine of theta. You have to apply the product rule to differentiating this. So it's going to be f prime of theta times cosine of theta minus f of theta times sine of theta. Because remember, when you differentiate this term, you're going to get a minus sine of theta. So f prime of theta times cosine of theta minus f of theta times the sine of theta. So not exactly a friendly form for which to have to deal with in order to calculate derivatives. No, but that's it. I shouldn't say derivatives. This is the slope of the tangent line. Do not confuse this with dr by d theta. Dr by d theta is how the rate of the radius is changing with respect to theta. As you vary theta, how fast is the radius changing? It's not the slope of the tangent line. So it's not equal to m. We're going to look at problem number 60 and calculate the derivative here. So our function is 2 times 1 minus sine of theta, basically a cardioid. And that factor of 2 is just going to make it a little bit bigger. We're going to want to find the slope of the tangent line at 0, at 7 pi over 6, and at 3 pi over 2. Now some of these should look kind of predictable. For instance, you should get a negative slope here, a 0 slope here, and an undefined slope here. Let's see that happens. So problem number 60. Let me distribute the 2. I'm not sure why they don't. So r is 2 minus 2 sine of theta. Keep in mind that this part right here, that's our f of theta. So if f of theta is 2 minus 2 sine of theta, what's f prime of theta going to be? Thank you, negative 2 cosine of theta. And basically we have to fill in this formula up here. That is f prime times sine of theta plus f of theta times cosine of theta, etc. It's not necessarily going to be a fun calculation. And we're going to have to slug through a fair amount of trigonometry in order to get to a simplified version of this. I'll help you out with it. So dy by dx. So dy by dx, I need f prime of theta, which is going to be minus 2 cosine of theta times sine of theta, plus f of theta. So let's go back to here, f of theta. That's going to be 2 minus 2 sine of theta times cosine of theta. So that's our numerator. I'm going to repeat this process for the denominator. So again, you're going to have f of theta, or f prime of theta, so minus 2 cosine of theta. This time we're going to multiply by cosine of theta minus 2 minus 2 sine of theta times sine of theta. So all I did was I filled in the information from this form of our derivative, slope of the tangent line. And we're going to have a long ways to go to clean this up. But right now it's just a basic calculation. You could plug in values of theta and get your slope. Nothing wrong with that. If you don't feel like plugging in this entire expression, then we can try and make this a little bit easier to deal with. So this is going to be minus 2 cosine of theta sine of theta. And if I distribute that, I get plus 2 cosine of theta minus 2 sine of theta cosine of theta. And I regret that I didn't write it in the same order as I did this, because these are actually like terms. So you've really got minus 4 of these terms up here. In the denominator, I get minus 2 cosine squared of theta. Distribute that, I get minus 2 sine of theta. Minus and minus a plus. 2 sine squared of theta. Again, we're going to clean this up a little bit. So these two terms are the same. They're like terms, I should say. So let's write that as minus 4 times sine of theta cosine of theta plus 2 cosine of theta. In the denominator, I'll put these two terms together as 2 times sine squared of theta minus cosine squared of theta. And I should have one more term left. It's a minus 2 sine of, minus 2 sine of theta. I haven't used that one yet. Yeah, I'm looking for my whiteout, for my Photoshop. Where'd it go? Here it is. Phew. All right. Minus 2 sine of theta. Now, one of the things I can do is I can divide out the 2 from all of this stuff. So that's going to be minus 2 sine of theta cosine of theta plus cosine of theta over sine squared of theta minus cosine squared of theta minus sine of theta. There's one last thing that I'm going to do to try and clean this up just a little bit more. Right here, this term is actually one that you have a nice trigonometric identity for. Does anyone remember it? Good. Sine of 2 theta. And this one is minus cosine of 2 theta. So let's clean that up a little bit more. Minus sine of 2 theta plus cosine of theta over minus cosine of 2 theta minus sine of theta. I think that's pretty good. You could actually multiply top and bottom by -1 and finally get something that's a little bit more comfortable to put into our calculator. And that would be sine of 2 theta minus cosine of theta divided by cosine of 2 theta plus sine of theta. So, wow. This thing, somehow or another, is the slope of our tangent line. Let's do two things. First of all, I'm going to plug in the function so that I can graph it. And then I'm also going to plug in the derivative so I can find values of the derivative, see what they look like. So as far as our function is concerned, let's take care of that part first. 2 minus 2 sine of theta. And then let's put in our derivative. I'm going to hit the alpha key, then the y equals key. That gives me a numerator and denominator. So in the numerator, I want sine of 2 theta minus cosine of theta divided by cosine of 2 theta plus sine of theta. So that's my derivative. I don't want to graph that, so shut off the graph for R2. So remember, go to the equal sign, press enter, and that'll toggle off that graph. Let me check my window here. The only thing I'm really concerned about is that I graph this from 0 to 2 pi. So 0 to 2 pi. Got our problem left from the last section where we graphed up to 4 pi. We're going to let our calculator do the work here. Remember the tricks in letting your calculator do the work? Once you have the window for theta adjusted, what were those two buttons? Zoom 0, followed by zoom 5. Okay, so that'll give you a nice graph. This one's just a little bit distorted because it's maximizing your space. If you wanted to see what it looks like when everything's all squared up, hit zoom 5. That doesn't really make a big difference in terms of your graph, but it is a little bit more realistic. So there you go. You get a nice cardioid. Talked about that before. Now, we want to find the derivative here at a couple places, and I've got that programmed in to my calculator. So let me shut this off, turn this on, and I wanted to find the derivative at 3 points. So I keep on saying derivative. I should say the slope of the tangent line. The first one was at 0. We can almost do some of that in our head, right? Because cosine of 0 is going to be 1. Cosine of 0 is 1, but I'll have a negative 1 in the numerator. These two disappear. I should get negative 1 at theta equal 0. So at theta equals 0, dy by dx, let's see what that is. Should be negative 1. Make sure your calculator is in radian mode. Go to the table. Let's delete all these values here. And just type in a 0. 0, and I get negative 1. That makes sense. That's what we expected. If you looked at the graph that you were asked to work with originally, then you expected a negatively sloped line here. Okay, that's fine. Wow, that's bizarre. All right, we don't need that graph. Let's take a look at what happens at some of the other points. One of them was 3 pi over 2. So 3 pi divided by 2 should give me a 0. Yay, it does. And that made sense as well because the slope of the tangent line there was 0. The last one was 7 pi over 6. So 7 pi and then divide by 6. Of course, when you hit enter, the symbol of pi is going to disappear, but the derivative should be, ooh, that's strange. This is as close as your calculator is going to get to showing you an error. So basically it's saying that the slope of this tangent line is negative 7 trillion is what it is. It's really, really steep. Basically, essentially vertical is what's going on there. You wouldn't want to ski down a slope with that. pitch. It'd be a hard landing. Now, let's go back to the graph though. So let me shut this off down here and go back to the graph. And I want to point out something important about the graph. If you hit the calc key, so second and then calc, it gives you a couple different options. One of them is the slope of the tangent line. We already calculated that. This one is how fast the radius is changing as you change theta. So let me choose this third one and calculate dr by d theta at 0. So you press the 0, this line opens up down here, and there you go. Slope of, the rate of change of r with respect to theta is -2. What's happening is that this thing is getting shorter at this rate, but it's not the slope of the tangent line. At 3 pi over 2, so let's do this again, calc dr d theta at 3 pi divided by 2, well, we got 0 there. That might be, yeah, that's because it was increasing and then the radius is going to start decreasing. So that one's maybe a bit of a coincidence. Let's check the last one at 7 pi over 6. 7 pi divided by 6. Okay, and I get the square root of 3 here. Well, the slope of the tangent line is certainly not the square root of 3. It's going to be vertical. It's going to be undefined there. So what I'm saying is that don't confuse on a test dy by dx with dr by d theta. If I ask you for the slope of the tangent line, you're going to need to calculate based on this formula right here. And if you absolutely need to, you can derive that formula much the same way that I did. R is f of theta, so you have x and y, dy by d theta, dx by d theta. You have to use a product rule for both of those. So that's your formula. One good thing you can do is write that down on the top of a test before you forget it. It's called a memory dump. Just write it down. Like, oh, you know what? I know I'm going to need that one. Write it down. There's nothing wrong with that. Okay, let me give you some homework, and then we'll move on to section 10.5. For homework, try 1 through 17, 23 through 31, 1 through 17, 23 through 31. You know what? Let's do 23 through 39 instead. 23 through 39. 43 through 47. 59 and 77 through 81. And these last few are just graphing.